So that. So Martin will be presenting something a little bit different, everyone. You'll be talking about moving data principles, and I think this is something interesting, keeping one eye a little bit on the future of where things are going. So please, Martin, take it away.
Yeah, many thanks, Kai. So some of you will have met me at this specific meeting 5 years ago in Amsterdam. And at the time I was employed with UK Research and Innovation at Dasbury Laboratory, and we were exploring CAPE-OPEN, including maybe CO-Lan and CAPE-OPEN as such in some proposals. And I, at that time, got interested in the community, but unfortunately nothing of this became in the meantime. But I'm still very interested. Now the question is, why have I come back, and why this esoteric topic? And this has a very simple answer. It's Kyle asked me to come, and he also proposed this title, moving from FAIR data principles to XAIR. That's a bit confusing. What is this XAIR? So let's resolve it right away. It stands for Explainable AI Ready. And what I will be summarizing, I assume a few of you are to different extents familiar with these lines of work. But nonetheless, I think that is what I should contribute here, is tell a bit what line of work has been pursued by the European Materials Modeling Council and Onto Commons concerning interoperability, and how this is going forward. So, and that is the big picture about this story. The FAIR principles, everybody knows them, and they were specified in the Wilkinson paper from 2016, having all these sub-items as you see them here, with a clear focus as you go through. Metadata keeps being mentioned, persistent identifiers. However, even for the metadata, the focus of the FAIR principle is not so much on actual semantics, on the meaning of what is communicated. It's more on making things work technically. So naturally, here I'm not proposing at all to abandon the FAIR principles. This is necessary. You have two kinds of two different codes that are supposed to exchange some information that must be interoperable. And so for that reason, work such as done in this community is essential. And also data that you want to work with, you need to be able to find and to access. Otherwise, nothing. So I'm not here arguing against the FAIR principles. What we see is a general tendency that more and more people argue that while this is important and needs to be done, for many purposes, we need some kind of guidance and good practices that go beyond that, and various names are circulating for that. And the main reason behind this is the stupid use that is being made of machine learning, right? So why has the whole development toward interoperability and metadata standardization even begun? Because people thought, yes, we bring all the data together, then we'll apply the machine learning and everything's going to work. Now the machine learning models that people are most obsessed with and are most popular, and also the most stupid ones. And this naturally poses a risk. Everybody knows this. You would not want ChatGPT to run a chemical process in any implementation. So we wouldn't need the European Union to regulate this, just to be aware of it. Also, the regulators are aware of that. And if in the European AI Act, this is expressed in terms of these two concepts, opacity and transparency. If we have some security critical system, we apply an AI system as a component of it, then what is dangerous is opacity. Something seems to be not clear, therefore opaque. And what is needed instead is the transparency to the engineers, to the regulatory authority, to everybody who needs that transparency. The expression opacity specifically refers to the discussion from epistemology and theory of science, and specifically theory of simulation, of epistemic opacity. And epistemic opacity simply means that some person, the user, or so the concerned agent, doesn't have clarity about here what is called the epistemically relevant elements, or what is it that establishes the knowledge status of some information. You can claim anything, give some data point, or critical temperature is this, azeotrope composition is this is a number. You can do nothing with it, specifically not in an automated system, unless you have some clarity about the knowledge status. And then the question is, you can communicate the knowledge status, you can say, oh, I'm very sure about this, but then you also need a handle on why should you rely on this statement? So something that establishes that. These are the kinds of epistemically relevant elements. And clearly, if we look back at the FAIR principles, they say nothing about this. Other sets of principles have been devised. There are a variety of principles. They are meant more for academic research, that you want to be open in all respects. We cannot expect the industry to be open in all respects about its information, so that is just a different concern. Other more ethical, but also epistemically relevant recommendations are formulated in the CARE principles. Those are very specific. They were really devised by this indigenous alliance from Canada and US mainly, about respecting the rights of the people who have generated or provided the data. So practices and recommendations like this could have a much more general scope, but this is a development that we have not seen yet. Good, so that's a basic landscape, and now let's look at what I said before that I would show, just summarize the development that has been coming out of the European Materials Modeling Council and the OntoCons project. Unfortunately, there has been some overlap between the communities, very little overlap with CAPE-OPEN community, which is a bit sad because the aims are quite similar, but that's how it is, so it deserves some mentioning. The European Materials Modeling Council, this sounds like a general name, but its focus has been really on interoperability and the use of multi-physics modeling in industrial digitalization. And for that purpose, then interoperability standards have been devised, both in terms of ontologies, but also more generic graphical standards, tables, how to fill in the information. And this is a standard, the level of standardization is the most accessible one in our community, CEN Workshop Agreement, CWA. This is for specifying a modeling workflow. A physics-based modeling workflow can also contain data-driven elements. And from 2018, nobody's really satisfied with that. And so how can we, what is there to learn of this exercise? First, it's good to have such a standards method and not to have it. But here we have so many things are being overspecified in the standard. So, for example, theoretically, every time you do a simulation, you want to document it according to that. For each element, for each simulation step, each processing step, each use case that you consider, and so on, you're supposed to fill in such a table. That's a lot. And in addition to being a lot, it specifies a given detail of documentation, a level of detail of documentation, which is a very high level of detail. But the major problem is that this is being fixed. Sometimes you may want a high level of detail. For example, if you want to specify a simulation workflow to the extent that it can be run. But if you only want to document it very superficially, to explain one or two basic facts to the user, then you need a different level of detail, and standards need to accommodate that. Okay, that's part. So, basic effort from the EMC community, we want to go beyond that and make it better. Another standard, CWA, which is from the CAPE community, is the model graphs. And the basic idea is process model topologies by Heinz Preissig from NTNU, which corresponds to a Petri net, which has these places and transitions and arcs, and they represent either at a certain level of abstraction flow of information, or flow of conserved quantities like matter and energy. So this was the status as a CWA. Now that seems to be similar in a few respects to DEXP, because that's what we have seen today. Correct? In DEXP we have representation of flow of information, but also a flow of matter and of energy, among many other elements. So that I found interesting, is maybe similar. Maybe I'm wrong.
Yeah,
you want to comment right away?
ModGraph seems to be doing behavior. DEXP is just doing structure. ModGraph's more like ModGraph's getting into the CAPE-OPEN area. You know, it's the Petri nets are behavioral things.
Yes. Okay. Yeah. You would say it is not meant as a data exchange specification. Yeah.
Yeah, they supplement each other.
Yeah. Yeah. Okay. That's a valid point. Then it just noted by looking at the document what kind of standards the DEXP work is referring to. Now, earlier today we learned that this is really not a good standard apparently, but just listed because it was mentioned in the document. Yeah. This is some work that maybe could be discussed together if the University of Oslo and NTNU are ready to talk to each other, then maybe they can have some discussions.
Yeah, but aren't you at horse?
Yes, yeah, but the main developer is the Heinz Preissig of the ModGraph.
Yeah, I know Hans.
Yeah. I'm interested in anything that you will discuss. Very interested. Just keep me in the loop. Okay, so here we have some standardization work coming out of this community. Major effort that has been very visible has been the OntoCommons coordination support action, like coordination support actions funded by the European Commission tend to do. Was meant to create a community with a focus on ontology-driven data documentation for industry commons. That was in fact the name of the project. And so the communities are the applied ontology community as such, industrial digitalization, but also the multiphysics modeling community as represented, for example, by the EMC. And the ontologies targeted are, as usual, at multiple levels, from the very application-specific one to the very abstract logical one with concerning foundational ontologies. At a foundational level, what has happened is that this work has harmonized different foundational ontologies under which we have many more specific ontologies, and therefore help the alignment and some specific alignment techniques called bridge concepts, how to document the semantic heterogeneity between ontologies that are supposed to do almost the same work, but have concepts that are not exactly the same. So work along these lines has been done. At a domain-specific level, first of all, many different industrial domain ontologies have been collected. At this level, in discussions, also CAPE-OPEN came up and is mentioned in a few documents. You were also personally involved in these discussions. And a study, different studies, for example, how fair are the ontologies themselves? Are the ontologies themselves well documented, and so on? Were done also a synopsis of what was observed across these domains of industrial digitalization was compiled. This is called RODI, the review of domain interoperability. The CSA projects only run for 3 years. So then the question came up, naturally, what is the long-term sustainability strategy? After we've brought together these communities, how can it be continued? And you know what is usually done, and people say, yeah, let's found an association, and this is what happened, and this association is called KGA, the Knowledge Graph Alliance. This is the successor to the Autocommons project, and continues to work. And in this context, we are considering this label that you've seen at the very beginning, XAIR, portmanteau. It's a portmanteau expression out of previously existing abbreviations. Everybody knows XAI, and also there was the abbreviation AIR, AI ready, and also we say explainable AI ready. We want to be ready for the challenge of making sensible use of data by explainable techniques. And explainable techniques, this doesn't only refer to neural networks making them somewhat explainable, but also integrating process simulation, molecular simulation, all kinds of physics-based simulation as part of what substantiates our trust or our reliance on certain data that come out of such workflows. So we want data, they should still be fair, but it should also be XAIR, so it should be fair and XAIR. That's the slogan. This work is established as a working group within the KGA. All can join the KGA. You can join as an institution and you have to pay, but there are many ways of participating in the work without having to pay. It's meant to continue this community forming spirit. And this particular working group has given itself a work program, even though we have no funding. That's also my general excuse. If you will ask me, oh, why is what you present here still so abstract and you cannot show the XAIR things? Yes, we don't have any funding for that. So we proceed slowly toward that goal. And the goal is within the coming years that we were able to say, these are the XAIR principles. Like we were saying about the FAIR principles. The FAIR principles also came out of some projects. And now why not develop recommendations from community discussions that are the next step. And with some discussions about that, where we want to involve the community right away. So for example, here we're supposed to create this synopsis of concepts. For that reason, we are organizing a workshop where people are supposed to come and tell us what they believe about a certain concepts that are relevant to explainable AI readiness, like what even is trustworthiness and what are operating conditions and so all the concepts that you would think are relevant. So such a synopsis are going to be discussed. You'll find a link here. You just need to look for, if you're interested in any way at all in the workshop, this is the abbreviation. It's easy to memorize. It's the devil's number. It's just a Roman numerals. So look for it if you're interested. Would be very good to have a discussion about this. Now, very briefly, what work has been done so far in that direction? So what we need to do is, as Humphrey said, we need to provide the epistemically relevant elements. Epistemically relevant elements to some information is here what we call the epistemic metadata. They are the metadata that establish the knowledge status of some element, some information. And so it's about what are we even saying? What is the claim? Where does it come from? Provenance, as we see all the time. Then how has it been tested, or its validity has been established, or has been claimed about its validity, including that it's, for example, claimed to be false. And why should I believe it? So under this category, we would have some kind of explanations. There would be some kind of grounding, provide some reason for us to accept it. Maybe because we're behind that, I shouldn't go too much in detail about these things. I want to mention that in the first round, we did case study in molecular simulation where we tentatively documented all sorts of claims and the provenance and the grounding for the content of a few papers from research groups at Imperial College and TU Berlin and from Kaiserslautern. And based on this, we developed some initial conceptualizations that can be reused or can be revised. How is it? So, how should I do the time?
We've got about another 10 minutes or so.
Yeah, it's fine. Okay, then I can say that some of the things that are a bit original, maybe don't know what you think about it, is that in together with the ontology development community from the EMMC, who developed the foundational ontology EMMO, we make use of the Peircean semiotics. And Peircean semiotics is a kind of, okay, it's from linguistics in a way. So semiotics is some kind of idea from linguistics. However, what this gives us is workflow documentation that has a flexible resolution. That's what I think is necessary. And generally, the idea is this so-called Peircean triad: sign, object, interpretant. So signification occurs in some kind of process. The process, now maybe I go to the next one, which contains this as an example. The process could be carrying out an experiment or doing a simulation. So I have a model. The model represents an object. But it doesn't do that statically in an abstract way. In this formalism, it represents the object in use. I do a simulation. That's a semiosis. Simulation is a semiosis. And as the outcome, I get the interpretant, which is another sign. It's the simulation result, which is about the same object. And with these kinds of triads, you can formulate what you did at a very high degree of abstraction. Just say, oh, this is my input, this is my output. Or you can go very much in detail and say, oh, no, this represents, this process consists of very many small elements that are connected like that. So that I found quite elegant from the idea of the EMMO developers. And that's also part of the basic approach here. Can be used for different kinds, can also be used for saying how certain claims are being formulated. Then we have the question of the validity, for example, concerning attempts at reproducing data. The question is, how do we formulate that? So the idea basically here is when somebody formulates a claim, either explicitly or usually implicitly, there is a claim co-formulated with it that if you do the same thing, for example, very similar experiment or very similar simulation, then you will get a very similar result. This is not being documented normally. If you look into a paper or a database, it doesn't tell you this exact degree of similarity of the simulation needs to be preserved, and this degree of similarity you will have in the output. But somehow this is understood. And of course, it would be much nicer if people documented such things explicitly. And if we have documentation standards for it, it will be much easier. In any case, there is some kind of reproducibility claim, which has the form of saying, if you do something like this, necessarily you get something like this. And the falsification will be just a negation. Somebody does something like this and finds something not like this. So it's a formulation based on this can be given. So we've seen some examples for what could be said about the knowledge claims, the provenance, the validation, and now the question is, how about the grounding, the explanations? This is very complicated because the explanations can have any form. Here you see a tentative classification. There are also ontologies that describe, existing ontologies that describe trust and reliance. A tentative way of classifying what kind of explanations there are can distinguish, first of all, between trust and reliance. So, for example, have we tested a certain model again and again? And no, yes, these are its operating conditions within that these operate with these bounds of thermodynamic conditions. For example, this model is valid to this margin of error. That relies. But sometimes we need to make a more or less explicit leap of faith and say, this is how it's, for example, this is how it's done in the community normally. I trust the community. I cannot check every single thing that all textbooks have established. I trust them. So, for example. So this is a distinction between reliance and trust. Another fundamental distinction that we can have is the grounding given by the results themselves, or is it rather the process that has generated the results? So take, for example, here a mathematical proof. For the mathematical proof, what matters is the result, it's the proof, right? Assuming the proof is the result. In that case, it doesn't matter how many discussions I had. Did I drink tea or coffee during the discussions? Was the proof by accident somehow, by a miracle written by ChatGPT, even though ChatGPT never can prove anything? Or monkeys with typewriters? It doesn't matter. The proof alone and the fact that it's correct, logically, mathematically correct, establishes its validity. But in other cases, the result itself establishes really nothing, as would be the case with the thermodynamic data point. Just the thermodynamic data point doesn't establish its validity. Here, it's all about the process. So these are the main distinctions that we have here. But just by saying that these kinds of grounding exist, and also we did some statistics about how frequent they are, we're not very far. So, but this is what I can recall about this line of work. We have a pre-existing ontology. This pre-existing ontology is unfortunately not very user-friendly. So it's in a process of revision. And this is what's going on now. We have a lot of time left. We have given ourselves a work program over, I think, 40 months. Maybe 30 of those months are still left, or a bit more even. And we're not in a hurry. Instead, it's really good to get input from the community, maybe have a bit more interaction between Knowledge Graph Alliance and EMC and CO-Lan in the future. So the communities are less isolated from each other. It would be very nice. I will not comment in detail about the digital passport. That's another topic. It would overextend the time. I put the slides in there because I think it's necessary to get my travel funded. Digital passport is very important, and I think CAPE-OPEN can also contribute to that by communicating, or next year also proper communication of information is necessary for digital passport. But I'll skip over that, and let's.
Which digital passport is it?
Okay, so
is it the manufacturing one, or is it the consumer goods one?
Here, this is another CSA,
Yeah.
DigiPass CSA, and it's meant to be the digital drug passport forming community for advanced materials.
Okay, so we get another one.
Yeah.
So yeah, okay, so the Industrial Digital Twin Association is doing one for manufacturing, and then the people who do barcodes are doing one for consumer goods. Okay, and where does yours fit in? Yeah.
The logic there comes from the clusters within Horizon, and this, and you know they have this this structuring between raw materials and advanced materials within the European Commission's policy making. And now they, for example, they're creating different academies, raw materials academy, advanced materials academy. And along these lines, they also support the creation of the digital passport.
Okay, so people who make chemicals are going to have to cope with about 3 different product passports.
I'm not very sure about that. Yeah, I cannot comment on the details of the regulatory process of the European Commission. So I'm really not the right person to ask about that. What you can see is that so obviously the digital passport is being introduced technology by technology, right? Beginning with the textiles, then with the batteries and electronics. And one of the fields where this next concretely being introduced is construction or building materials. And that will be one of the focus areas of our use cases in the project. And that's also because the partners have a background in coating, and coating materials then can be used also as part of building materials, and that's how this connection will be made. So right now, I assume the next standard digital passport, concrete formulation of the digital passport that will be regulated and is relevant to this project would be for building materials. But those are the outcomes that they are produced by the chemical industry. So they're quite relevant. Yeah. Yeah. Here the background is mainly in coating and pre-painted metals, but I think that thermal insulation materials and others would also be included in such a regulation effort.
Okay.
Yeah.
So someone who's making something for Airbus using advanced composites would use this as a passport into their passport.
Yeah, right. Yeah,
Okay.
right. These are products from the chemical side, but then in the manufacturing side, they are materials that are used for the production. Yeah, right. That's the DigiPass CSA project. I hope it will lead us to some success with the digital passport. But we're also quite at the beginning, right? The project started in April, and it will run over 3 years. And yeah, so I assume there will be some need to consult the chemical industry within this project.
Can you go back to the partners?
No. So coordination is Helmholtz-Zentrum Herion, Institute for Surface Science. Yeah. Maybe you recognize some in that case. Yeah.
Not a question, but a comment. Let's talk after your presentation about the digital material passport of the IOGP.
Mhm.
It sounds similar, so we have to see if there's an overlap.
Yeah, let's do that. Okay, I didn't expect that. You should have asked me to focus on the digital product passport. Good.
Thank Martin. Right, we will have a short 10-minute break, and then we'll reconvene